Hello all. So today's target is data pipelines. So we'll start discussing data pipelines in the sense many times we get confused data pipelines with ingestion of data, where we know that ingestion is one of the steps of data pipeline. So what basically data pipelines deal with is they'll be dealing with data movement, processing patterns of ETL, ELT, data sharing, etc. So basically a data pipeline is a combination of architecture, systems and processes. Your data pipeline can be a traditional on-premise transactional systems using a monolithic processor and written onto a data warehouse. Or a data pipeline can be your cloud-based data pipelines. It may be using pulling data from 100 sources, combining them into 20 white tables, train 5 other ML models, deploy them into productions, and monitor ongoing performance. So what they say is data pipelines basically are the backbone of modern data engineering. So what data pipelines involves is movement and processing of data through stages. The stages of a data pipeline can be collect the data, ingest the data, store the data, compute the data, consume the data. So here it is clear that ingestion is one of the steps of or one of the stages of data pipeline. So no need not be getting confused an ingestion of data with data pipeline. So data pipeline supports different tasks like ETL, ELT, reverse ETL, data sharing, etc. So many of the literature I referred, it uses the water analogy to understanding the data pipelines. We have water, and the different sources of water can be lakes, oceans, rivers. So similarly, we have data. So the different sources for data can be data lakes, databases, streaming data. So your databases can be your DynamoDB data or MySQL data, PostgreSQL data, and so on. So a water treatment is done to the source of water, such as filtration and purification. So similarly, data is treated with ETL, replication, virtualization. ETL stands for extract, transform, and load. Replication is for redundancy. You can have, say, a server which is replicated. You might have heard about replication factor in Hadoop, say 2, 3 is there. So the simple meaning of that is the similar data will be there at some other zone or at some other server. If that particular server is not available or the crash has occurred, through replicated data we can get back. And virtualization sometimes is used whenever from the data source you have to directly process the data, then virtualization will be used. So what we are doing here, we are trying to do a water versus data analogy to understand this data pipeline concept. So why we use data water pipelines? To forward the data to homes, to agriculture, to factories, etc. Similarly, your data pipelines will be used to transport the data to BI experts or ML users and so on. So as mentioned, the stages of a data pipeline can be collect, ingest, store, compute, and consume. You have something called as batch processing versus stream processing. What is the meaning of stream processing? The meaning of stream processing is that the data will be real time and it may be some sensor data coming from a factory, it may be some IoT data. So it may be every second the data is pouring in or every millisecond the data is pouring in. So for stream processing, the tools which can be used are Apache Flink, Google Cloud Data Flow, Apache Storm, Apache Samza. Similarly, there will be some uh, batch processing which involves some frequency like a backup every 24 after every 24 hours backup may be taken kind of thing or after every 1 hour the data is being sent like that. So this is what is batch processing, and the tools which are suitable for batch processing can be Apache Spark, Apache Hadoop MapReduce or Apache Hive. Now coming to different tools which need to be mentioned in data pipelines are, if you want for ETL, you can use Apache Airflow or AWS Glue. For storage, you can use Amazon S3, HDFS, Snowflake, Amazon Redshift, Google BigQuery. For real-time data, you can use Apache Kafka, Amazon Kinesis. So real-time data examples can be, which are stream oriented, can be sensor data from factories, stock market analysis. Batch data examples can be monthly sales report or customer data aggregation. Now, data pipelines are pretty flexible. They'll be taking care of traditional ETL systems on-premise, monolithic. They'll be taking care of cloud-based ecosystem, which are multi-source and ML ready. So Apache Kafka again is for streaming. It combines messaging, storage, and stream processing. Amazon Kinesis again is for real-time streaming at scale, and it is suitable for AWS environment. So this was in short a brief description of data pipelines, wherein we try to highlight how data pipeline is different from ingestion. Rather, ingestion is one of the stages of data pipeline, and through water versus data analogy, we made a comparison, and so that it becomes easier for us to understand what a data pipeline exactly is. And we mentioned different tools like Spark and Flink and Storm and Hadoop and Hive. So this was a short video regarding the data pipelines.